Hello Algebra and welcome to day 1 of Pythagorean Theorem. Day 1 of 4, so we're going to spend quite a few days on the Pythagorean Theorem because it's a really important topic. This is a topic that you'll cover a lot in geometry, but it's really important in Algebra 2 and trigonometry. So Pythagorean Theorem, although we're going to learn it in Algebra, it's going to be a reoccurring theme. Our essential question today is, can I use and instead of writing the Pythagorean theorem like a million times, I'm going to use P period T period as a little abbreviation for Pythagorean theorem. Can I use the Pythagorean theorem to, and what does the Pythagorean theorem do? To find a missing side length. And a missing side length of what, and we're going to go into detail on that. So Pythagorean theorem, here is one or two big things you need to know. Firstly, I'm going to write the Pythagorean theorem. Pythagorean theorem only works on, so if we're going to be finding missing side lengths, we're going to be talking about like geometric pieces, and it only works on right. And again, I'm going to be pretty lazy again. Instead of writing out the Pythagorean theorem every time, I'm also not going to write out triangle every time. It only works on right triangles. So when we're talking about the Pythagorean theorem, in order to find a side length, it can't just be any triangle. You need to start with a right triangle. Please draw out a right triangle right now. So it has to start with a right triangle. And the Pythagorean theorem is an equation, or a formula, if you will, that's true about every right triangle. Pythagoras, although there's a little bit of drama of if Pythagoras actually came up with a Pythagorean theorem, or like if one of his little disciples or students or whatever did, but he gets all the fame and glory, so whatever. So he came up with an equation that works for every single right triangle. And you've probably seen this before. And maybe it's just been a matter of, oh, okay, like now I know what we're doing. I've seen this before. Now I can actually put it to use. And so how does this relate to this? What's going on? And we're looking for missing side lengths. A, B, and C each correspond with a specific side of a right triangle. I'm going to use two colors even though there are three sides. And this is why I do that. I picked up the wrong color. Because A and B are both legs, and a leg is the two shorter sides of the triangle. And the reason I'm using both of them in pink and both of them are called legs, because it doesn't matter which one's which. If this is 5 and that one's 3, it could be A and B, or it could be B and A. It doesn't matter, as long as you pick one to be A and one to be B. The only thing that really does matter is you need to make sure C, or whatever side length it's equal to over here, is that longest length, or the hypotenuse. And in class, we'd have a whole bunch of fun saying hypotenuse and not hippopotenuse or hypotenuse or anything, but hypotenuse. Read it as it's spelled there. That is the longest side, and it also doesn't touch the 90-degree angle. So in this case, the hypotenuse is that green there because it's not touching the 90-degree angle. So the hypotenuse is pretty important because that's the one that matters. That's the one that needs to be on the side opposite the two legs, and it's opposite the 90 degrees. So let's see how I can use that to find a missing side length. Like now we know what it is, let's see what we actually need to do. So if you followed along so far and you're like, okay, like I get it, but like how is this gonna look? You're on the right track right now. Please draw a 90-degree triangle. Mine will never be drawn to scale, I'm pretty sure, especially if I'm drawing them, so yours don't have to be either. Okay, we are looking for the hypotenuse. So which one is the hypotenuse? And that's the one we're looking for, so put an X there. And then the two side lengths that are legs, the two legs, are 3 and 2. And then you plug in everything to the Pythagorean theorem and solve for what you don't know. So the goal of Pythagorean theorem is plug in what you do know, solve for what you don't. In this case, I know my two legs. I am going to use the same colors. If you're like over the colors by now, that's fine. But I really think it can be helpful the first few problems that you do this. So we have a squared plus b squared is equal to c squared. And at this point, we know what to plug in where, hopefully, if we pop back up here. So the two legs are a and b. It doesn't matter if it's 3 squared plus 2 squared or 2 squared plus 3 squared, because you can add them in any order. So I'm going to pick 3 to be a, but you could pick 2 to be a and then 3 to be b. It doesn't matter as long as one of them is being used for each. And then c is that hypotenuse, but unfortunately we don't know what the hypotenuse is. So that is our goal, is to find out what x is. And at this point, I'm going to do this. I just found some 2 random pieces of paper. I could have, and probably did, give you a problem that looked exactly like this a few days ago. Probably like a week ago. And I said solve for x. So we want to know what x is. We're trying to get x squared by itself. We already know that. Awesome. What is 3 squared plus 2 squared? It is not 5 squared. It is not. So one way of doing this, the way that I prefer to do it, is I just do it in my head. I say, well, what's 3 squared? Well, that's 9. What's 2 squared? That's 4. That's how I prefer to do it. But if you just want to jump ahead and say, okay, well, what's 3 squared plus 2 squared? It's 13. You can jump that piece right there and go directly from here to there. And you can just add those up. Don't just add up the bases there. Don't do 3 plus 2 is 5. No. You actually have to simplify each individual piece. At that point, we're almost done. We're trying to get x by itself. X is being squared. You are going to undo the x squared by square rooting both sides. So let's do that to both sides. We're going to square root here, square root there. We're trying to get x by itself. That crosses out. X is equal to the square root of 13. And technically it would be plus or minus 13, but we can't, or this plus or minus the square root of 13, but you can't have a negative side length. So at that point, you're technically done. I like to write my answers like that. But both of those answers are correct. Well, they're the same, but that's correct. I'm going to do one more simple problem, and then there will be another video with a little bit more in-depth examples. Ooh, I drew that line like way too long. That's okay. Example 2. I'm going to draw my triangle a little bit differently just to kind of mix it up and show you that not all triangles need to look exactly the same, but if you just want to stick with it, make all of your problems look the same, that's fine. They don't have to be drawn to scale. Okay, your hypotenuse is 10. So your hypotenuse in this case is given. That's 10. One of your side lengths is 6, and it doesn't matter. You could put, I'm going to put it here because I know that my answer is going to be longer than 6. And in this case, you know one leg and you know the hypotenuse. We're going to plug stuff in and see what we know. The two legs are touching the 90 degrees. And the hypotenuse is 10. Again, I love colors. I think it makes everything just stick in my head. But if you want to skip that, that's fine. While I have that line there, I might as well just use it. Okay. Do I know what A and B are? I do. Those are the legs, and it doesn't matter which one's which. I'm going to start with the X for A, but you could have put the 6 for A. And do I know what C, which is my hypotenuse? Yes, that would be 10 squared. And at this point, we are going to solve this. Let's take my handy dandy little pieces of paper here again and say, hey, I bet you know how to solve this problem. Your first step, subtract 6 squared from both sides, but, please do this first. I really think this will be helpful. Simplify those specific terms right away. That makes your life a little bit easier. Then, we're going to subtract 36. I don't know where I was going with that, so that crosses out. X squared is equal to 100 minus 36, which is 64. And I like that number because when I'm getting x by itself and I square root both sides, what is the square root of 64? The answer is 8. So in this case, if I'm looking for my unknown, I plugged in everything I knew. So I plugged in the b and the c. I got everything on one side to get that x squared by itself. And I found that that missing side was 8.